Alright guys, welcome to your last semester 2 practice of the year. We're going to be doing graphing quadratic equations, and we're going to be doing a bunch of different kinds of activities with graphing quadratic equations. So we'll be doing all of this stuff. We're going to find the x-intercept of a parabola, we're going to find the vertex, we're going to learn or practice graphing a parabola, and we're going to solve an equation by graphing. So a bunch of stuff today, just really getting comfortable with parabolas. So the first thing, it says finding the x-intercept and the vertex of parabola. Find the x-intercept and the coordinate of the vertex for the parabola y equals x squared minus 8x plus 12. If there is more than one x-intercept, separate them with commas. So we are going to be finding the zeros. That's what it means when it says find the x-intercepts, or sometimes you might have heard it called finding the solutions. So we can use factoring, something you spend a bunch of time on, or we can use the quadratic formula. At this point, it's kind of your choice which one. Not every equation can be factored. Every equation can be solved using the quadratic formula. So it's kind of up to you. I'll show you both methods here. Okay, so we'll try factoring first. Here's our equation. So we need to write down A, B, and C. Should be familiar by now. And that's going to help us find our magic numbers. So A times C is 12. And we need to think of factors of 12 that add to B, which is negative 8. So 6 and 2 can be added, the negative versions can be added together to give you negative 8. So we will rewrite this as negative 2x minus 6x, which is negative 8x. So you'll see that here. So x squared minus 2x minus 8x, that just replaces our 8x, plus 12 equals 0. And then we factor by grouping. So we will pull an x out of these front two, and we'll pull a 6 out of both of these. Notice that what's in the parentheses is the same. That's good news. Then we can rewrite this x minus 6 and x minus 2 would be our two factors. That equals 0. Set those equal to 0, and then we can solve x equals 2. Take the other solution, x minus 6, set it equal to 0, and we get x equals 6. So those would be our answers for the x-intercepts. And we should get the same thing if we do the quadratic formula. So let's just check to see that we do get exactly the same thing. The quadratic formula looks like this. Same problem. We've got A, B, and C. We're going to use those to plug into the quadratic formula. So A is 1, B is negative 8, C is 12. And you know the familiar quadratic formula. We'll just plug that in. So remember, it's x equals negative b. That's negative 8 is b, plus or minus the square root of b squared. So negative 8 squared minus 4a, which is 1, c, which is 12, all over 2a. So now that you've plugged it in, you can simplify it quite a bit. We'll do negative times a negative. It gives us positive 8 out front. Negative 8 squared is 64, and then negative 4 times 1 times 12, that should be 48, all over 2 times 1 is 2. So you can see that. And I went one step further, which was to take 64 minus 48. That gives you 16. And here's where we are. We can find our positive and negative roots. So up here we'll do 8 plus everything, and on the bottom we'll do 8 minus everything. So here we have 8 plus root 16. Root 16 is obviously 4. 8 plus 4 is 12 divided by 2. We get, we'll get our answer here in just a moment. And then on the bottom we have 8 minus root 16. That ends up being 8 minus 4 all over 2, which is 4 over 2. So this 12 over 2 is going to give us x equals 6. And on the bottom, it gives us x equals 4. So that shouldn't be surprising. Or x equals 2, I should say. Shouldn't be surprising. That's what we got when we did it by factoring. Remember, the quadratic formula is just a different method to solve the same question. We're going to check that by graphing. Actually, I'm sorry. Let's type that in real quick. So we got x equals 6 and x equals 2 as a solution. Remember, we did that both ways. The next thing we need to find is our vertex. And just a quick, I'm sorry, we're going to find our line of symmetry, and then we'll find our vertex. So the line of symmetry is the x value point of the vertex. I'll show you graphically what that looks like in just a bit. We're going to use the line of symmetry formula and then enter the x value into the original equation and then solve for y to find the y value of the vertex. So we're looking for a pair of coordinates, pair of coordinates to give us the value. So this is the equation for the line of symmetry. X equals negative b all over 2a. That's the first half of the quadratic formula. And the way that looks is something like this. So we have that same formula we've been dealing with, y equals x squared minus 8x plus 12. And to find our line of symmetry, we're going to do that first, and then we'll find our vertex. So that looks like this using the formula b over 2a. So that's negative 8 over 2 times a. So that'll be negative times a negative gives us positive 8 all over 2 gives us x equals 4. So that's our line of symmetry. So far we know the x value is 4. That's our line of symmetry. And then what we do is we plug in x into the original equation to find out the y value of our vertex. So here is our original formula. So you can see I plugged in x, so 4 squared, and negative 8 times 4 plus 12. We just do the arithmetic now. That's 64 minus 48 plus 12 gives you y equals negative 4. Okay, check that yourself. So we have 4 and negative 4. That's the position of the vertex on the graph. So we would type in, we got our x-intercept was 6, 2, and our vertex using the line of symmetry, and then finding the vertex, we got 4, negative 4. Let's quickly check this. I've graphed the parabola on Desmos. So you can see there are our two x-intercepts at 2 and 6, and our vertex, which is the bottom of the parabola, is 4, negative 4. There you can also see our line of symmetry. So there's our x-intercepts, our vertex, and our line of symmetry. I graphed just the line x equals 4, and you'll notice it cuts our parabola right in half. Symmetry means that if you folded it on a piece of paper, it would look identical, and you can see that this parabola looks identical on either side of this blue line. That is our line of symmetry. So we used the line of symmetry to find the vertex, and we used factoring or the quadratic formula to find our x-intercepts. All right, so I want you to try this as well. Take a moment, see if you can find the x and y intercepts and the vertex for this parabola as is instructed here. Go ahead and give that a try. All right. And again, that's 1, 2, and negative 24 respectively. Then we need to find the magic numbers. So what numbers multiplied together give us 24 and add to 2. So 4 times 6 is 24. If we cram a negative up front, we have negative 4 plus 6. That is 2. So we can rewrite this with our magic numbers. That would be x squared, and then the 2x becomes negative 4x plus 6x from our magic numbers. Minus 24 equals 0. Then we can group. So we group these two together and factor out an x. We group these two together and factor out a 6. And then we can rewrite this. Notice we have x minus 4 in both spots. That's good. So that would become x minus 4 and x plus 6. Those equal 0. Setting those equal to 0, we have x equals 4 and x equals negative 6 as our solution. All right, let's try that with the quadratic formula. We should get the same answer. So once again, we have a, b, and c, plugging those in. So there's b, which is 2. There's b again, squared, which is 2. 4 times a times c, all over 2a. So this is just going to become negative 2. You have 2 squared, which is 4. And then you have minus 4 times negative 24. That's 98, positive 98. And then that's going to end up adding to 4. So you get 100. So square root of 100 all over 2. So negative 2 plus or minus square root of 100 all over 2. Now we can separate these into our roots. So the plus root will be negative 2 plus root 100 all over 2. So that would be root 100 is 10. Negative 2 plus 10 is 2, or all over 2. So we have 8 over 2. And then we have on the bottom, take the subtraction. So this is still 100, negative 2 minus 10, which is negative 12 all over 2. So here, 8 over 2, that's x equals 4. Down here we have negative 12 over 2, that's x equals negative 6. So we got the same answers, and we're going to now find the vertex using the line of symmetry. So remember the equation for that is b, which is 2, all over 2a, which is 1. So we have negative 2 over 2, which is negative 1. So we know that our line of symmetry is x equals negative 1. Now we plug that back in to find the vertex. So negative 1 squared plus 2 times negative 1, negative 24. So we get y equals negative 25. So our vertex is negative 1, negative 25. Okay, so this is a very different type of question now. It'll say, use this graph. It will provide you with one to fill in the table. And it's going to ask you several different things to do just to get you comfortable using the graphs of quadratics. And it asks if it opens upward or downward. This one should be pretty easy. Remember our little acronym you've been learning from your algebra class, or mnemonic, which is that it opens up like a cup, so it opens upward. If it was down like a frown, it would be downward. Okay. Next, all you have to do is use the graph to fill in the remaining stuff here. So on this one, it asks us to find the equation of the axis of symmetry. So I drew that nice line there. You can see it passes right through the 4. So the equation of our axis of symmetry is just x equals negative 4, or if in ALEKS, you can just type negative 4 as your answer. Okay. Next, it asks you to graph the parabola and fill in the table, continuing with the same question. So finding the coordinates of the vertex, it's just going to be at the bottom there, which is the coordinate negative 4, negative 1. The last thing that it's going to ask you is to find the x-intercepts. So where does it cross? It crosses pretty obviously right here at negative 6, right here at negative 2. Those are our two x-intercepts, and you'll just type that in as your answer. Okay. This one's kind of odd. We haven't done anything like this before, but it just asks where is the y-intercept, and you can just look to see where it crosses, and it happens to cross right here. So the y-intercept would be at positive 3. You can see it right there. So far, we haven't been doing a lot of that, but that's a pretty straightforward question. You know what y-intercept means. All right. Okay, on to our last question. Here, it gives you a parabola, and it asks you to graph it making a table. So there's a strategy for how to do this. Because parabolas are symmetrical, they're the same on either side of the line of symmetry, we can actually start with the line of symmetry. So here is our parabola, and what we'll do is plot 5 points. We can plot, and it tells you which ones here to use. The vertex, 2 points to the left, 2 points to the right, and then you will graph the function in ALEKS. So finding the line of symmetry, that's negative b over 2a. So if you plug that in for here, b is 6 and a is 1. So we have 6 over 2, negative 6 over 2, which is negative 3. And so that would go in for our x value. And if you plug that in for the formula to get our y value out, we get negative 3 squared plus 6 times negative 3 plus 8. That all ends up being y equals negative 1. So we have our first point here, that's negative 3, negative 1. The reason we use the vertex to do that is we know that we're going to get a nice point out when we do that, compared to possibly some other points that might not come out so nice. It's also going to help us figure out what to plug in next. So then we'll find the zeros. Here we've chosen to do that by factoring. And once you find those zeros, you actually know that y is going to be 0 at those points. Those are really convenient things to plug in. And so we end up with negative 2 and negative 4 as ours. You may need to pause the video to comprehend what I've done there, but I've just factored it, plugged in the x values, and y is 0 at those zeros, hence the name zeros. Okay. Last, we'll pick some numbers that are pretty close to our x-intercepts and between our x-intercepts and our vertex. So I plugged in negative 2, and when you do that, you get, I've plugged in ones that are close by. So I plugged in negative 1, and when you do that, you happen to get 3 out. And I plugged in negative 5 because it's near this other 0, negative 4. And when you plug that in, you also happen to get 3. It's not surprising. Notice that this is our middle number, our vertex. And then the two above it have the same y values, and the two above that have